So last time we were doing this, we were talking about one path is equal to the other path. That is what we were up to. Definitions currently thi, and we had started talking about that when you talk about enthalpy changes, no matter how you make the products, that is irrelevant. Carbon plus oxygen directly make carbon dioxide or take another path. The enthalpy changes of the two routes is going to be exactly the same. Okay, no matter what path is taken. So we were doing that, and I'm going to try and do more questions. So we're going to try and do this specific question. Okay, I'm going to try and do this over here. Okay, in this question, he's asking you to figure out the enthalpy change of this particular reaction. So I'm going to write it over here. It's calcium solid plus aqueous minus 2 electrons, and you're trying to make calcium 2 plus aqueous. So the whole question is you're supposed to figure out the enthalpy change of this particular reaction. You have to figure out this thing. So the rule is that no matter what path is taken, the enthalpy change would be exactly the same. So if you start at this point and you're trying to reach the other point, so you could have taken this completely other path, and the enthalpy change would have been exactly the same. So we're going to try and figure out this other path. So so we're going to try and figure out this other path. Now the two reactions given, the enthalpy changes are known. So I'm going to try and figure out the steps how to make calcium 2 plus aqueous using this other path, which needs to be created. There is one thing that is missing over here, and that is which was taken from the data booklet, and that is that calcium gas turning into calcium 2 plus gaseous ions plus 2 electrons. This has a value of 590 plus 1150. So we have basically three reactions. This is what I've taken from the data booklet. ये भी कहाँ से आया, where you figured that out? हम बाद में सोचेंगे. You've got three reactions. You have to create this other path. So the first thing is I'm going to take reaction number one. Let's focus on reaction number one. Calcium solid turning into calcium gas. I know the enthalpy change. So I see calcium solid over here. What I'm going to do is I'm going to turn it into calcium gas, leaving everything else the same. So everything else kind of remains exactly the same. The only thing I've done is I've changed calcium solid to calcium gas, and the energy that is required for that is 177 kilojoules per mole. So that is one small step. Remember, I have to reach this other place. I have to reach this point. So the first thing is calcium solid turning into gas, solid turning into gas. We're done with that. Then we have this equation that calcium gas can be turned into calcium 2 plus ions. So what I'm going to do is I am going to connect this equation now. That if I have gaseous calcium, which I do have over here, what I can do is I can turn that gaseous calcium and I can turn that into calcium 2 plus 2 electrons. So again, I'm just focusing on calcium. First thing, I turn it into gas, calcium solid turning into gas. I knew the value. Now what I'm doing is I'm turning calcium gaseous into calcium 2 plus ions, and they lose 2 electrons. The other thing remains exactly the same, plus aqueous. So it's plus aqueous and minus 2 electrons. So the enthalpy change for this is 590 plus 1150. So stepwise, I need to figure out, I need to go from this point. This is my start. And I need to reach this end over here. And I'm trying to create this completely other path. I'm trying to create a cycle. So calcium solid turned into gas. I turned it into gas. Calcium gas then turned into calcium 2 plus ions. And its value was given in the data booklet. That's 590 and 1150. The last step is I need to go from this point to this point. So if I look at this last step, so what is happening is calcium 2 plus gas plus aqueous, these two electrons would eventually get cancelled out. I mean, it doesn't make sense. You've got plus 2 electrons and minus 2 electrons. So it's this equation, calcium 2 plus gas reacting with aqueous and turning into calcium 2 plus aqueous. This value is minus 1565. So I've figured out this completely other path. I've connected all the reactions together, and I've started at this point and I've reached this other point. Okay, pehle solid turned into gas. Then the gas got ionized and turned into calcium 2 plus ions, and it required 590 and 1150 kilojoules of energy. And then lastly, the calcium 2 plus gas plus aqueous, it turned into calcium 2 plus aqueous, which is this step over here, which is minus 1565. And the last thing I need to do is that one path is equal to the other path. So the very last thing that needs to be done is this is path number 1. And here's your path number 2. So path 1, we were trying to figure out path number 1. So path number 1 is basically the same as path number 2 because you're reaching the same endpoint. So we're going to follow path number 2. It's 177 plus it's 590 plus 1150. And then you have minus 1565. And you'll get your answer if you, I mean, you were looking for path number 1, so you'll find your answer if you solve this, TK. So is this thing clear? Mahad, is this clear? Anya, Sidra, is this clear?
Yes.
So, and what is the value that we're getting? Is this coming out to be, I think it's going to come out to be plus 352. That is the value that we're going to get. So, so we're going to try and do another question. TK, remember doing these questions, these are one of the toughest questions. And then we're going to move towards a formula. There's a formula that will work sometimes. And that formula is really simple. So we're going to move to that formula after this. So I'm going to try and do this question now. Okay, I don't have space, so I'll copy this. So let me copy this on the board. So let's try and do this question now. Now, if you look at this question, a few things need to be understood first because, I mean, this triangle, I'll just tell you what this triangle means. It's part of organic chemistry. It's another representation of organic molecules that you'll study later. So the first thing is, what is this triangle? This is cyclopropane. It's basically 3 carbon atoms arranged in a cyclic manner, and each one has hydrogens attached to it. So the triangle is this thing. Now, the whole question is that they're saying that the enthalpy change of formation of cyclopropane is given. So that's the first part. That they've given the enthalpy change of formation of cyclopropane, which is C3H6. I mean, this thing is your cyclopropane. It's C3 and H is 6. So that's the first part. So I'm going to write this reaction. So cyclopropane, enthalpy of formation. Enthalpy of formation is, it's the energy change that is associated with that reaction where 1 mole of cyclopropane is going to be formed from its constituent elements. And its elements are carbon, which is solid, and the other element is hydrogen, which is going to be in gaseous state. And there are going to be three of them, and they're going to be three carbons as well. So that is the first part. Sorry. So that's the first part, the enthalpy of formation of cyclopropane. And they've calculated the value as well. That's 53.3 kilojoules per mole. So what was enthalpy change of formation? It was when 1 mole of a substance is formed from its constituent elements, and the elements need to be in the standard state. So I figured that out. Okay, so we're done with the first part. Now, what we're going to try and do is, remember, if we have a Hess cycle, we would be able to figure out whatever they're looking for. So if you're able to connect reactions together in a cyclic format and you get the same product, then the two parts would have the same energy change. So we're going to try and build this other part now. So in the next part, he says that the enthalpy change of atomization of graphite is 717. So it says that the enthalpy change of atomization of graphite, remember, is carbon. So enthalpy change of atomization of graphite basically refers to this thing. Okay, atomization is when you form 1 mole of gaseous carbon atoms from its element, and the element is graphite, which is solid. So that is the enthalpy change of atomization of graphite, that you make 1 mole of gaseous carbon atoms. And he's given us the value, it's 717 kilojoules per mole. So that value is given to us. So iska kya karna hai? What I can do is, I see carbon solid over here. What I can do is, I'm going to turn that carbon solid and atomize it, because he just gave me atomization. So I'm going to do that. So I'm going to make or turn the carbon atom into gaseous carbon atoms. And I'm going to keep the H2 as it is. I'm not touching the H2, so nothing is happening to it. That is as it is. So in this particular step, the only thing that's been done is that carbon has been atomized, or graphite has been atomized. So the energy that would be required for this would be 717, but times 3, because the reason I'm multiplying it by 3 is because I've got 3 carbons. I'm turning 3 solid carbon atoms into 3 gaseous carbon atoms. Is this clear? Reid, is this clear? Ospa, is this clear? Mahad?
Yes, sir.
So I've reached this point. I've only read the question here. He gave me enthalpy change of formation. I wrote down the enthalpy change of formation. He gave me the value. It was 53.3. 1 mole of substance formed from its constituent elements. And then he gave me atomization. He told me that the atomization of graphite is this. So I just saw carbon solid and I just atomized it. I made atoms out of it. And now, what's the next information that he's giving me? He's giving me that the bond energy of HH is 436. So what I'm going to do with that is I'm going to break the HH bond. So do you see the HH bond? I see those H2 bonds over here. So what I'm going to do is, let's keep carbon as it is, not touching the carbon. I'm going to break the HH bonds. So I'm going to get 6 hydrogen gaseous atoms when I break those bonds. So how many HH bonds did I break? I broke 3 of them. 3 HH bonds are broken. So he told me the energy for breaking those bonds. The bond enthalpy was given for breaking the HH bond. So I just did that. I broke all the 3 hydrogen molecules and I got 6 hydrogen atoms. So when I did that, the energy that would be required for that, remember it's breaking, so it's endothermic. So that would be 436 plus positive. and it's going to be times 3. Then moving on, what do I do after that? Now he gave me the CH bond. Now the only thing is I'm left with atoms now. Like if you look over here, I just have atoms. So what I'm going to do is I'm going to try and make the product now, which is C3H6. So how many bonds do I have to make? I've got 3 carbon atoms and 6 hydrogen atoms. So I need to make this C3H6 molecule. So how many bonds do I need to make? I need to make 6 of these CH bonds, CH, CH, CH. So 6 of them. And I need to make 3 CC bonds. So if I want to make this molecule from this point and complete the cycle, I would have to make 3 bonds of carbon and carbon. And 6 bonds are to be made for carbon and hydrogen. And since I'm making bonds, this value would be negative. It's exothermic. Remember, bond formation is when you're forming bonds, that's exothermic. So he gave me the bond in enthalpy of the CH bond. So I know the CH bond, that's 6. So I'm going to just replace this with -6 times, because the bond energy of CH was given just over here, and that is 410. So the only thing that's not given is the CC bond energy, and he's asking you to calculate the average bond enthalpy of the CC bond. So I'm going to repeat everything. He gave me the enthalpy of formation of cyclopropane, which is this thing, C3H6. So he gave me that. So 1 mole of compound is formed from its constituent elements. The value was given 53.3. Then he told me the value for the atomization of carbon. So I just did that. I atomized carbon, turned it into gas, and this value was 717 times 3. Then he gave me the value for breaking the HH bond, which was 436. And you're breaking it, it's going to be endothermic, it's going to be positive. So I broke all the 3 HH bonds and I got 6 hydrogen atoms. The carbon remained as it is. And finally, I had all these atoms, so I just got them together to form the C3H6 molecule, which is basically this cyclopropane molecule. And all that needs to happen now is, so I got these atoms together, made 3 CC bonds and 6 of the CH bonds. 3 CC bonds need to be made, 6 CH bonds, and they should be exothermic. So one path is equal to the other path. So there's only one unknown in this whole thing. So this is path number 1, P1, and that's your path number. So that's path number 2. So I'm going to equate the 2 paths together, and I'm going to write, so it's path 1 equal to path 2. Both the end product is the same, so which is why the enthalpy change or the energy change of the 2 paths is going to be exactly the same. So path number 1 is 53.3. Path number 2 is 717 times 3. Then it's 436 positive times 3. After that, it's did I miss anything? -6 times 410. And then I'm making these 3 CC bonds, which I don't know what the value is. So all I need to do is now I need to make CC the subject of the equation. So what can be done is, just rearrange the term. It's going to be bring the 3 CC bonds to the other side and to this side. So can somebody calculate this? 717 into 3 plus 436 times 3. And it's -6 times 410. And you've got minus 53.3. And all you have to do now is divide everything by 3. So you get rid of the 3 on this side. And that's it. So what are we getting for this? So can you try and calculate this?
I think it's 350.
You're getting 350 yaar hai. I mean, it is 350 because 351, just 1 second.
No, 315. 1-5.
1-5. Okay, so this appears to be the answer. I said, just make sure, be very careful. When you're trying to solve this, be very careful that in O levels, you're not used to doing a lot of math on your calculator. It's mostly 1 or 2 numbers or 3 numbers at best. But be careful when you're adding too many numbers and subtracting too many numbers. There's a lot of room for errors. So just make sure you use your calculators very, very carefully when you solve this. So 315 is the answer. Like, is this clear? Also, is this clear? Is that clear?
Yes.
So then we can try some. So we did most of the questions yesterday when we did these questions. So now what we're going to do is we're going to move towards formulas now. So remember, doing these questions is kind of tough and it requires, and remember, there are 2 ways of doing this. There is one way is to draw the Hess cycle. There's another method which usually doesn't always work. So and Cambridge expects a lot of times to actually sketch the Hess cycle as well. So which is why you have to kind of get good with sketching the Hess cycle, because sometimes there are a couple of questions where they might ask you to sketch the Hess cycle. But at the end of the day, I told you that if you get 10 questions, then most of the questions don't require drawing the Hess cycle. There are very few questions that actually require drawing the Hess cycle. For the other questions, instead of drawing the Hess cycle, there's a simple rule and a simple formula, but the formula is conditional. There are actually 2 formulas. So we're going to talk about the Hess Law Formulas. These formulas make things very easy, but the only problem is they're not always applicable. So they are conditional. So under certain conditions, you can use formulas, not always. So for example, you've got this reaction. You've got W plus X, and it's reacting to form Y plus Z. So you've got this reaction. Now, the formula says, and it's conditional, the formula states that if you're given, the reaction could be anything. It doesn't matter what the reaction is. So what the formula states is that if you're given the enthalpy of formation of W as well as X of the reactants as well as the products. So if somebody gives you the values of the enthalpy of formation of the reactants as well as the products, all you have to do is, if you're trying to figure out the enthalpy change of this reaction, all you have to do is that the enthalpy change of the reaction is simply the enthalpies of formation of the products. You sum them up minus the enthalpies of formation of the reactants. So that is the formula. For example, over here, what you're going to do is that if they give you the enthalpies of formation of the products, so what you're going to do is you sum up the enthalpy of formation of Y, and you sum up the enthalpy of formation of Z. That's your products. And you subtract it from the enthalpies of formation of your reactants, which are W and X. So that is what the formula is. That, but it's a conditional formula. For this, you should know the enthalpy. I mean, so the only possible way you can use the formula is that if you know the enthalpies of formation of the products as well as the reactants, so you don't have to draw the Hess cycle. So we're going to try and practice these formulas. For example, they're looking for the enthalpy change of this reaction. Now, the enthalpy change of this particular reaction is going to be, okay, what you're going to do is you're going to, so they're looking for the enthalpy change of this reaction. So what they're going to do is that the enthalpy of the products, so the enthalpy of this particular reaction is basically the enthalpy of formation of the products. So the enthalpy of formation of SO2 is given over here. That's minus 297. So you're going to sum up the products minus 297, and it's going to be multiplied by 2 because there are 2 of them. And the enthalpy of formation of the other product, which is water, which is minus 286, and that's going to be multiplied by 2 as well. And you're going to subtract it from the reactants. The reactants are H2S. So the enthalpy of formation of the reactants, that's minus 21 times 2. And for elements, the enthalpy of formation, remember, is always 0. So if you solve this, can you try and solve this? What do you get for this? Sidra, Osma, can you try and solve this?
A.
Okay, so you're getting minus 12. That's again, you'll be getting 2 different values. So make sure you use your calculators properly. Okay. Like if I try and solve this, okay, so I'm gonna try and solve this. So it's remember brackets. Make sure you put brackets in your calculator. Minus 297 times 2. So then it's minus 286 times 2. So it's minus 286 times 2. And then it's minus 21 into 2. So that would become plus. So it's going to be plus 21 times 2. And I get B minus 1124. So just make sure your calculation and the signs, there's nothing wrong with the signs. This last one would become positive because products minus reactions. Enthalpy of formation of the products. So it's the delta HF of the products minus the delta HF of the reactants. So you're getting B for this. Now, every time you don't have to draw the Hess cycle. You could have drawn it, but it's going to be time consuming. So the simple method is take the enthalpy of formation of the products and subtract it from the enthalpy of formation of the reactants. So all questions would pretty much be solved in the same way. For example, if you look at this question, he's asking for the enthalpy change of this reaction, the combustion of methane. Methane is CH4. You need to burn it. So it's going to produce CO2 plus H2O. And it's going to produce 2 H2O, and it's going to produce 2 oxygen molecules are present as well. अब इसमें ये कि what is given? He's given you the enthalpy of formation of carbon dioxide, that's minus 394. He's given you the enthalpy of formation of water as well, that's minus 286. And he's given you the enthalpy of formation of methane as well, that's minus 74. And the enthalpy of formation of oxygen is 0. So what is the formula? The enthalpy change of this particular reaction is going to be products, the enthalpy of formation of the products. So it's going to be minus, so I'm going to put a bracket, sum up the products, minus 394. And then it's minus 286. And that would be times 2 because they're 2 water molecules. And I'm going to subtract the reactants, which in this case is just methane. So that's minus 74. So the enthalpies of formation of the products, subtract it from the enthalpy of formation of the reactants. So what are we getting? So we're getting minus 892. Okay. Minus 892. So the question now becomes very simple. It's just, I mean, you just have to apply the formula and you'll be able to solve the question very, very quickly. Next one, it's exactly the same. What is given? The enthalpy of formation of Mn, I mean, this one is given, this is minus 696. So they've given that enthalpy of formation of MnO2 is given, that's minus 520. So the enthalpy of formation of NO2 is also given, that's plus 33. So all of this is provided. So all you have to do is the enthalpy change of this entire reaction is going to be, I mean, product. So that's your product minus the reactants. So it's going to be minus 520 plus 33 would be times 2. That's your products. And minus the enthalpy of formation of the reactant, which in this case is minus 696. तो क्या आ रहा है इसका? ठीक है, we're getting 242 for this. So pretty much all the rest are going to be exactly the same. Here's another one. Some questions would be slightly tricky. For example, this one is, what is the enthalpy change of combustion of propanol? So I'll write the equation. Propanol is this thing, C3860. You can Google this. So enthalpy change of combustion, where 1 mole of a substance burns in oxygen to produce, and it's going to produce carbon dioxide and water, and there's going to be 3 carbon dioxide and there would be 3 water molecules, and you can balance the oxygens. So it's going to be 326, 3 is 9, so that's 402. So this one, what is provided? He gave us the enthalpy of formation of propanol. So this one is minus 254. So this one is given. One of the enthalpies of formation is given. This one is 0. For elements, the enthalpy of formation is 0 because you don't have to form them. The enthalpy of formation of carbon dioxide and water is missing. He did not give us the formation values. But instead, he gave us the combustion values of hydrogen. So 1 mole of hydrogen burns in excess oxygen to produce H2O. He gave us this value. This is minus 286. And he gave us the combustion of carbon as well. So 1 mole of carbon would burn in oxygen, excess oxygen to produce carbon dioxide. And he gave us this value. This was minus 394. So the thing is that, the question is, remember we discussed that certain reactions can have multiple labels. He's calling it enthalpy of combustion of hydrogen. We can call it the enthalpy of formation of water because both labels represent the same enthalpy change and the same reaction. Enthalpy of formation of water represents 1 mole of water being produced from its elements. The enthalpy of combustion of hydrogen represents the same reaction. And we can call this the enthalpy of formation of carbon dioxide, because 1 mole of carbon dioxide is produced from its constituent elements, and it is getting produced from its constituent elements. So the thing is that that he gave us the enthalpy change of combustion, but we're going to read it as the enthalpy of formation of carbon dioxide. So this value is given to us. And he gave us the enthalpy of combustion of hydrogen. We're going to read it as the enthalpy of formation of water, which is minus 286. Okay, so this was just the tricky part that he gave us combustion, which was in fact the enthalpy of formation of water. So all you have to do now is products minus reactants, add up the products and subtract it from the reactant. So it's going to be minus the enthalpy of the reaction would be minus 394 times 3 and minus 286 times 3. That's my product, and you subtract it from the reactant, which is minus 254. So Oscar, you've calculated this, right? So is this clear?
Yes.
So the answer is you're getting C. So the answer is C. So just be careful. So it's a simple formula, which is, but the formula is conditional. For this, you need to know the enthalpy of formation of everything. So the formula is simple, which is that the enthalpy of formation of the products are known, and the enthalpy of formation, and specifically it's the enthalpy of formation. This should be known. And the enthalpy of formation of all the reactants should be known. Then you just sum up the enthalpy of formation of products and subtract it from the enthalpy of formation of the reactants. You have to be very careful with the signs. So make sure you put brackets. These are your products subtracted from the reactants. So be very careful with the signs so you don't mess up the signs. So these questions, I mean, this way, most of the questions are going to be like this. That enthalpy of formations, I mean, we haven't done combustion. Most of the questions are going to be very straightforward. This reaction, he's given us the enthalpy of formation of everything. O2 is 0, but the other ones are already given. So it's going to be products minus the reactants. So here, let's talk tomorrow. TK, we'll do the other formula in the next class. TK. Okay, everyone, take care. Allah Hafiz.